Hello students, we know how to find the complementary function of the equation f of d dash operated on z is equal to 0. Now we see some examples of that type. So to find the complementary function of the following or solve the equation, first is d cube minus 6d square d dash plus 11d into d dash minus 6d dash cube operated on z is equal to 0. So we solve these 5 equations one by one. So what is given equation first? Solution of first, d cube minus 6d square into d dash plus 11d into d dash minus 6d dash cube operated on z is equal to 0. Now you know that d means dou z by dou x and d dash means dou z by dou y, or d dash means dou y. So first you find, or first you write the auxiliary equation of this equation. Already you are given symbolic form. The auxiliary equation of 1 is so how you find the auxiliary equation? You put d is equal to m and d dash is equal to 1. So auxiliary equation is m cube minus 6m square into 1 plus 11m d dash is equal to 1 minus 6 into 1 minus 6 is equal to 0. So you find the factors of this auxiliary equation. So this is a equation in cube, or degree of this equation is 3. Therefore this polynomial has 3 factors, means 3 roots. So here you observe that m is equal to 1 satisfied this equation. If you put m is equal to 1 cube, here 1 minus 6 plus 11 minus 6 means minus 6 minus 6 12, and 11 plus 1 12, 12 minus 12 0. Therefore m is equal to 1 satisfies this equation. Therefore m minus 1 is one factor. M is equal to 1 satisfy this equation. Therefore m minus 1 is one factor. So how you find other factors? By making use of synthetic method. Using synthetic process, we have, so already you know that process. Here m is equal to 1 satisfied means here 1. You write the coefficients of the given equation: 1 minus 6, 11, then minus 6. Here cross means 1 into 1 1 minus 5 into 1 minus 5. Here 11 minus 5 6 into 1, here 6 minus 6 plus 6, here 0. Therefore your factors are here m minus 1 and here m square minus 5m plus 6 is equal to 0. So m square minus 5m plus 6 is equal to 0. Therefore m minus 1 into, so what are the factors of m square minus 5m plus 6? 2 into 3, 6. So its factors are m minus 2, m minus 3 is equal to 0. So here you get m minus 1 one factor, m minus 2 another factor, and m minus 3 third factor. Therefore your roots are, therefore m1 is equal to 1, m2 is equal to 2, and m3 is equal to 3. So you get 3 roots. Now using these three roots, you write the general solution of given equations. Given equation is number 1. Therefore, complementary function of 1 is, your roots are m1 is equal to 1, m2 is equal to 2 and m3 is equal to 3. So complementary function is z is equal to, that is phi 1 y plus m1x plus phi 2 y plus m2x plus phi 3 y plus m3x. So these are the distinct factors. Therefore you have this. Therefore z is equal to phi 1 y plus m1 is 1, y plus x plus phi 2 y plus m2 is 2x plus phi 3 of y plus m3 is 3x. So this is the required general solution of given partial differential equation 1. So in this way you find the complementary function of given partial differential equation when the roots are distinct or different. Then we solve second example. So what is second example? Second is solution of second. D square minus 3d dash plus 2d dash square operated on z is equal to 0. Suppose this is number 1 or given equation. So already the equation is in symbolic form. Auxiliary equation of 1 is, auxiliary equation of 1 is, what is its auxiliary equation? M, you put d is equal to 1, m and d dash is equal to 1. M square minus 3m plus 2 is equal to 0. So m square minus 3m plus 2 is equal to 0. So its factors are, this implies m minus 1 into m minus 2 is equal to 0. Therefore m1 is equal to 1, m2 is equal to 2. Or you can write m minus 2 into m minus 1 is equal to 0. What may be? You take m1 is equal to 2 or m2 is equal to 1. Therefore complementary function is equal to, z is equal to phi 1 of y plus m1x plus phi 2 of y plus m2x. Therefore z is equal to phi 1 of y plus x plus phi 2 of y plus 2x. You replace m1 is equal to 2 or m2 is equal to what? No change. So this is the required general solution of given partial differential equation. Now we solve third. So what is third? Solution of third. Third is d raised to 4 z by, dou raised to 4 z by dou x raised to 4 minus dou raised to 4 z by dou y raised to 4 is equal to 0. So this equation can be written in symbolic form. D raised to 4 minus d dash raised to 4 operated on z is equal to 0. So what is auxiliary equation? Auxiliary equation of 1 is m raised to 4 minus, you put d is equal to m and d dash is equal to 1. 1 raised to 4 is equal to 0, or m raised to 4 minus 1 is equal to 0, or this can be written as m square minus 1 square into m square plus 1 square is equal to 0. M square minus 1 square, So m1 is equal to plus minus 1. So this implies m1 is equal to 1, m2 is equal to minus 1. M square minus 1 means here m minus 1, m plus 1. So m minus 1 is equal to 0, therefore m is equal to 1. M plus 1 is equal to 0, therefore m is equal to minus 1. Similarly here m square plus 1. So its factors are m square plus 1 is equal to 0. M square is equal to minus 1. Minus 1 means I square. I square is imaginary unit. Value of I square is minus 1. Therefore m square is equal to I square. Therefore m is equal to plus minus I. Therefore you take m3 is equal to I, m4 is equal to minus I. So your roots are 1, minus 1, I, minus I. Therefore complementary function is equal to z is equal to c1 phi1 of y plus m1x, y plus m1 is 1, y plus x plus phi2 of y plus m2x, y minus x, then plus phi3 of y plus m3x means ix, then plus phi4 y plus m4x means y minus ix. So this is the general solution of given partial differential equation 1 d raised to 4 minus d dash raised to 4 operated out z is equal to 0. Now similarly we solve remaining. So fourth, dou 2z by dou x square plus a square dou 2z by dou y square is equal to 0. Again this equation can be written in symbolic form. D square plus a square d dash square operated on z is equal to 0. Therefore auxiliary equation of this equation is, auxiliary equation of 1 is, what is the auxiliary equation? M square plus a square is equal to 0. So m square plus a square is equal to 0 means m square is equal to minus a square. Minus a square can be written as here minus 1. Minus 1 means I square, a square. I is root minus 1. I square is minus 1. Therefore value of m is equal to plus minus ia. So you take m1 is equal to plus ia or ai and m2 is equal to minus ia. So you have two roots. Therefore complementary function of 1 is equal to phi1 of y plus m1x. m1 means ia, y plus ai or iax plus phi2 of m2x, y plus means here minus iax. So this is the required general solution of given partial differential equation. It means only a complementary function. Here again I and minus I are distinct. Now last, fifth. So given equation is this. So symbolic form of this equation is d cube minus 7. Here d cube z by dou cube z by dou x dou y square means 7 d into d dash square plus 6 d dash cube operated on z is equal to 0. Therefore, auxiliary equation of one is auxiliary equation of one is, what is auxiliary equation? You put d is equal to m is m cube minus 7 m plus 6 is equal to 0. Here 6 plus 1, 7, 7 minus 7. Therefore, m is equal to 1 satisfy this equation. Therefore, m is equal to 1 satisfy this equation. Therefore, m by a synthetic method. So, you have 1. So, its coefficients are here 1 minus 1 0 minus 7 6. Here 1, here 1 1, then here 1, then minus 6 into 1 minus 6, here 0. Therefore, factors are m minus 1 into m square, here plus m, then minus 6 is equal to 0. Therefore, m minus 1, here m square plus m minus 6, then 2 into 3, 6, means its factors are m minus 1, m minus 2, then m plus 3, minus 2 plus 3, 1. So, is equal to 0. Therefore, from this, you have m1 is equal to 1, m2 is equal to 2, and m3 is equal to minus 3. Therefore, complementary function of given equation is, therefore, complementary function of given equation is z is equal to phi1 of y plus m1x plus phi2 of y plus m2x plus phi3 of y plus m3x. Therefore, z is equal to phi1 of y plus x plus phi2 of y plus 2x, then plus phi3 of y minus m3 is 3x, m3 is minus 3. So, this is the required general solution of given partial differential equation. Here we have seen the complementary function, how you find the complementary function when the roots are distinct. Next lecture we say if the roots are repeated roots, then how you find its general solution. So, we stop here. Thank you.